So Ben is originally from Arizona, graduated from the University of Arizona. He received his master's degree from Kansas State, where he focused on forage quality and drought-tolerant forages. Currently, Ben is a PhD student at the University of Wisconsin-Madison, working on improving forage quality and digestibility. And his presentation is entitled "The Effect of Forage Processor Roll Gap Settings and Storage Length on Whole Plant Corn Silage Harvested at Different Maturities."
Thank you, Dr. Borman, for that introduction, and I really appreciate the opportunity to be a part of this program today. Just trying to advance my slide here. Okay, so I want to begin by talking about the importance of corn silage for the dairy industry, and this is a concept that I'm sure is familiar with everyone here. The corn silage is a critically important feed ingredient for the dairy industry. Last year, 130 million tons of corn silage were produced in the United States alone. And in the diet of a modern dairy cow, silage can constitute up to 60% of the diet dry matter. And so therefore, its high inclusion really demands that we have a thorough understanding of all of the nutrients that corn silage provides. Obviously, this would include starch and fiber and their respective digestibilities. But it also includes some nutrients that we often overlook in silage research, like silage fatty acids and amino acids. So we know that there are many factors that influence quality and digestibility of corn silage that's produced on dairy operations. Some of these factors are biological in nature, such as hybrid type, environmental conditions, or plant maturity. Others are management related, so they would involve things like cutting height, kernel processing, and storage length. We also know that stored silage is a dynamic system, and it actually undergoes numerous chemical and structural changes over the course of storage. So that brings me to this particular experiment that we conducted. The objective here was to evaluate the effect of forage harvester roll gap width settings and length of storage on fermentation profile, corn silage processing score, and in situ starch digestibility of whole plant corn silage harvested at 3 maturities. So briefly, samples from a single corn silage hybrid were harvested at 3 maturities. In this case, we harvested at 1/4, 1/2, and 3/4 kernel milk line. And for the sake of this experiment, we called those maturities early, intermediate, and late. And then the harvested corn was processed through rolls with gap settings of either 1 millimeter or 3 millimeter, and that was done using a self-propelled forage harvester. And then the harvested and processed silage was stored in quadruplicate vacuum bags like the one shown here for 0, 30, 120, or 240 days. So we really wanted to get an idea of what happened kind of later on in the really later stages of fermentation. And then we analyzed these samples for fermentation profile, nutritive value, and corn silage processing score. And we're actually still collecting the in situ starch digestibility data, so those results aren't available at this point. So I want to share some of my results. We'll kind of start with looking at the effect of our treatments on nutrient composition and fermentation profile. So overall, with our study in particular, we did not find much of an effect of plant maturity or roll gap settings on silage nutrient composition. We did, however, find that lactic acid concentrations were greater with early and intermediate silage compared to the late maturity silage. However, we did find that storage length had a greater effect on nutrient composition and fermentation profile. So here are some of the results in this table below. The first that I want to share is talking about soluble crude protein concentrations. So what we can see is that there was a significant effect of ensiling. Now this is just comparing 0-day and 30-day means. And there was also a significant effect, a linear and quadratic effect of storage length on soluble crude protein concentrations as well. We also observed significant effects of ensiling, as well as linear and quadratic effects of storage length on concentrations of water-soluble carbohydrates. Interestingly, we observed a linear effect of storage length on corn silage processing score. So as storage length increased from 30 to 240 days, we actually saw an improvement in corn silage processing score. So now let's talk a little bit about the amino acid profile of this silage. So similar to what we saw with the nutrients and fermentation profile, plant maturity and roll gap settings only had minor effects on silage amino acid profile. However, we did again see a greater effect of storage length. So briefly, obviously we did analyze for multiple amino acids, but I'm kind of just focusing on some of the main findings here. But we found a significant effect of ensiling, as well as linear and quadratic effects of storage length on lysine concentrations, as well as the sum of all essential amino acids, non-essential amino acids, and the sum of total amino acids. And generally, kind of big picture, what we see is that as storage length increases, we see concentrations of amino acids going down, and this is most likely due to deamination reactions in the silo by plant and microbial proteases and other enzymes. So practically, what does this mean? So let's take a look at lysine, for example. So if we have a cow that's consuming 50 pounds of dry matter, and if that diet contains 50% corn silage, what that means is that the 30-day corn silage will be providing about 28 grams of lysine per day. That's under the conditions of our study. The 240-day corn silage will be providing 25 grams of lysine per day. So just kind of some things to think about and think about whether that has any effect on actually how we formulate diets. Now, finally, we'll take a look at the effect of our treatments on fatty acid profile. So like we've seen before, plant maturity and roll gap settings had minor effects on silage fatty acid profile. And again, storage length had the greater effect here. I do want to say, so in this table, I'm focusing primarily on 3 unsaturated fatty acids, oleic, linoleic, and linolenic acid. The reason I'm focusing on these 3 in particular is because these 3 fatty acids are known in the rumen to be the precursors to those specific CLAs that can inhibit milk fat synthesis. And there is some concern that given the high inclusion rate of corn silage and the fact that corn silage is supplying considerable amounts of unsaturated fatty acids, that high corn silage diets might predispose cows to diet-induced milk fat depression, or at least put them at a greater risk. And so what we found with our silage was that there was a tendency for a linear effect of storage length on concentrations of oleic acid. There was a tendency for there to be a effect of ensiling and a significant quadratic effect of storage length on concentrations of linoleic acid, and a significant effect of ensiling and significant linear and quadratic effects of storage length on concentrations of linolenic acid. I think one thing we just have to take note of is, while we did observe some differences here, the magnitude of these differences is relatively small. So the question is, will this really have a practical effect, on the cow physiology? And we also observed a significant quadratic effect of storage length on total long chain fatty acids and a significant linear effect of storage length on free fatty acids. And the reason I chose to focus on free fatty acids here is because, as we know, free fatty acids compared to fatty acids in the form of triglycerides or glycolipids tend to have more of an inhibitory effect on digestion in the rumen, particularly fiber digestion. And so there is some concern that silage that's been stored for a long period of time might be supplying more free fatty acids and could potentially be detrimental to digestion. So again, I kind of want to talk about this practically. So if we have a cow that's consuming 50 pounds of dry matter and 50% corn silage diet, under the conditions of our study, 30-day corn silage would provide 109 grams of free fatty acid per day. The 240-day corn silage would provide 136 grams of free fatty acid per day. So again, there is kind of a difference in the supply, but it's our opinion that it would be unlikely that corn silage would really put cows at a greater risk of developing diet-induced milk fat depression. And kind of just for some perspective, a typical diet would contain about 545 grams of total fatty acid. That's assuming that the diet contains about 2.4% fatty acid in the diet. So just to wrap things up with some conclusions and implications. So under the conditions of our study, we found that maturity and roll gap had little effect on corn silage quality. However, we do know in the field that these are factors that are important, and so they should definitely be considered carefully. We also believe that it's unlikely that the fatty acids that come from corn silage that's been stored for a long period really put cows at a greater risk of developing diet-induced milk fat depression. And then finally, while storage does little to affect corn silage fatty acid profile, we did find that amino acid profile might be affected to a greater extent. And this would have implications for diet formulation, especially as our understanding and practice of precision feeding increases in the future. So yeah, with that, if we have time, I can take a question, but yeah, thanks again for this opportunity.
Thank you, Ben. And type in questions on the chat. And then I just had a question about between your quarter and your 3/4 milk line, how many days was that difference in harvest time?
It was about 7 days difference.
Okay, so we're not talking about a large difference then in harvest time. You're likely in a bunk of silage potentially having that whole range.
Yeah, of course, Dan. That's a good point. And under the conditions of this study, obviously the dry down rate at which your silage matures would be affected by environmental conditions and other things like that. So.